Well, thank you very much for inviting me. These are my disclosures, which are not relevant except for the Carl Zeiss, because I will point out some things on veracity, which I get paid to consult on making it better, but not to sell it to you. Now, there's lots of things that could go wrong with cataract surgery, and luckily most of these are quite rare. What are you judged on every day? You're judged on this. What are your refractive outcomes, both by your patients and by your colleagues? And so optimizing this is probably one of the best things you can do to improve patient satisfaction. So these are a couple of things that I just have out here as assumptions as we go forward, looking at the modern day calculations. And first, it's that every patient I have, every surgery I do undergoes a tear film tune-up automatically. When I meet them, they have to go through this, and then 2 weeks later, then I'll do the biometry and measurements. Now, you have to objectively evaluate the tear film. I'm using Cassini and Keratograph right now, no financial interest in either company, to be sure that you have proper tear film mechanics before you do the biometry and the topography. You have to make sure all biometry meets your validation criteria, especially with the lens star. And if you're using Hill RBF, you have to have an inbounds calculation. So all these are assumptions as I go forward with my talk. This is an example of the Cassini, and this is a bad tear film. You should not be doing biometry or keratometry on this eye. Tune this up or you're going to get a bad result. This is a good tear film on the Cassini. All these squares are squared up and lining up with each other. This is a patient who came to me insisting they had prior myopic LASIK. I don't believe that. This does not look like prior myopic LASIK, but this is a 42 diopter K, 42 and a half. Tune up that tear film. This is the same patient, and it's actually a 39 diopter K. So that would be a big miss for this patient who's already paid significant money in the past to be spectacle-free. These are the IOL power calculation methods in 2019. I think you recognize a lot of these, the Holiday, Hoffer Q. These are just kind of old, faithful. You can always turn to these, but you have to have normal anterior segment anatomy for these. My biggest piece of advice to you today is use an IOL calculation from this century, okay? So it's 2019. You got Olsen, which is a ray tracing formula. You have Barrett 2 now, the most sophisticated Virgins formula with thousands of line of code and lookup tables and conditions. And then, of course, now in 2018, we have Hill RBF 2.0. It's the only artificial intelligence program that actually has an inbounds indication. So the beauty of Hill is it's going to tell you if you should use it or not. Why is this important? Well, if we look at our traditional formulas, the vast majority of surgeons end up within a half a diopter of refractive accuracy only about 3/4 of the time. Now, that means if you're doing premium IOLs, 25% of people are going to be unhappy with their refractive result. That's unacceptable. We have to do better. Only the top 1% of surgeons who optimize the tear film and optimize their A constants can use these older formulas and still hit above 90% half diopter accuracy. If we look at the first Hill RBF study from 2016, we can see that all surgeons, if they follow the assumptions I previously gave you, can get 91% of patients within a half a diopter of refractive accuracy. This is a little bit better with normal eyes. It's a lot better with myopic eyes. This is the weak point in all formulas, and that's only 85% of patients with axial hyperopia can hit the plus or minus a half a diopter of accuracy. If we look closer at these particular numbers, again, the Hill is around 85, Holiday is almost a 50-50 shot. Hoffer Q is traditionally the short eye formula. It's only about 75%. And Barrett and Olsen do a little bit better. Again, that's the original Hill. Now, how does RBF work? Did you know that RBF is only looking at 4 factors? The spherical equivalent is the target that you're aiming for. The original RBF, just based on 3,500 eyes, was about plano. Now you see the green dot show up there. That's a spherical equivalent of plano and an axial length of 26, not too far off of normal. And then you mix in K's of 44, and now you're still within bounds. And finally, a pretty normal ACD. This is an inbounds calculation for a more or less normal eye. You have a 90% plus chance of being within a half a diopter of the refractive accuracy you're looking for. Let's expand the boundary model of Hill now by adding 12,000 eyes. You can see that the shaded area is much larger. Let's look at a weird eye. We want to aim for plano, and we're going to take a long eye, 28 millimeter axial length. Suddenly we're inbounds. What if you had a long eye with steep Ks? Not common. Previously, this would have been an out-of-bounds calculation, but we've expanded the model with more eyes, and now it's in bounds. And then a short anterior chamber depth. This, again, is a very strange eye. Would have been out of bounds. Now it's in bounds. So the enhancements for Hill RBF is that now in 2018 you can actually aim for myopia. Here's minus 1.3 or minus 2.4. You see that it changes the power of the lens. We've got so many eyes now with 7,000 more cases that out of bounds calculations for normal eyes is unusual. Axial myopes are better, and we can go down to -5 lenses. and we've expanded the hyperopic range now with another 1,000 eyes. Now, Barrett is another one that I use a lot. It's a great all-around divergence calculator. It's my post-refractive calculator of choice, but I really want to focus today on the integrated K because it's producing a median vector solution for toric, power, and axis. So you can take LensStar, an IOL master, and a topographer, or any three that you like. You can get the median vector solution, which is more accurate for toric IOLs. As a matter of fact, in our practice, we're hitting 90% or better within a half a diopter. So for all torics, I recommend the Barrett formula, especially with the integrated K. Now, I do this on every eye, whether it's a toric or not. And how do I do this? Because there's too much room for transposition and transcription errors. I'm using veracity. It automatically brings in all this data with no errors. With 3 clicks, I choose which 3 machines I want to use. It immediately gives me the integrated K solution and then puts it into the formula and tells me exactly the toric solution. Finally, today I want to talk about the EKR65. This is actually a very important but overlooked value here. You get it on the Pentacam from the holiday report, and it gives you the 65% mean, both peak and average. At the 4.5 millimeter pupil zone as a standard, you can choose a smaller pupil zone if your patient does have that. It's adjusting keratometry for the back surface, and in normal eyes, the EKR65 is very similar to what your normal keratometry will be, but for keratoconus, PK, corneal scars, irregular astigmatism, I believe the EKR65 is better. Look at this keratoconus eye. We have an average K of around 60. I think many of you know that if you take the standard keratometry readings, you're going to get a hyperopic result in keratoconus, so you give a fudge factor of 1 or 2 diopters or maybe 3 diopters of myopia. But looking right here, we can see that the EKR mean 65 and the same eye is only 56 diopters. Using this number will save you a 4 diopter hyperopic miss in this keratoconus patient. So it's very important to look at that. So to conclude, in my practice, I use Hill and Barrett, and when they agree and all validation criteria are met, including using the integrated K, I'm at 95 to 97% of eyes within a half a diopter. The True K is my choice for refractive surgery eyes. The toric calculator with the integrated K is better than 90%, and EKR65 for abnormal corneas. Thank you very much. I appreciate your time.
Questions?
Yuri, that was beautiful. I mean, what has happened is, so many of these formulas have simplified the process for us, which is great. Do you do anything specifically different for longer axial lengths, 26 millimeters, shorter axial lengths, 22 and lower?
Well, if you're using some of the older formulas, you must put in, for example, the Wang-Koch adjustment. There's no additional adjustment for Hill or Barrett. And there's also no optimization of A constants for Hill or Barrett.
The Hill RBF was developed in cooperation with Hogstrite, and so they have, I guess, the licensing on that. Do you see that expanding to other devices at some point?
Oh, I don't want to talk for Hogstrite or Warren. But the basic rule for RBF is if you want to play in the sandbox, you have to share data. Because that makes the RBF stronger the more data we get. So I'll leave it to that.
How good is Hill RBF at this point for post-myopic LASIK and PRK eyes? Do they have enough data for post-LASIK and
for the Hill?
Hill.
I'm not allowed to speak about that right now. We are working on Hill 3.0 though, so for non-post-refractive eyes it's still doing well. But the Barrett does quite well for post-refractive eyes.
What do you use to calculate posterior corneal astigmatism?
Well, one point I'll make is that right now for Barrett and the posterior corneal astigmatism, the predicted works better than the measured, but we do expect that to change. I have Cassini and I have Pentacam, and we don't quite know which is better right now.
And Yuri, what do you do when the Hill, because you said you look at both of them, the Hill and the RBF, correct? Or the Hill RBF and the Barrett. What do you do when they don't agree? Which one do you favor?
Yeah, that's a very good question. What do I do when Hill and RBF don't agree? I stand up and I walk 4 feet away and I drop the chart in Warren's desk. I say, because he wants to know, when does this not agree? And I say, tell me why this doesn't agree. And I'm learning, but I'm not Warren Hill. And I'm learning why. And he'll point out to me, this is where it went off the rails, and here's why it doesn't work. So I do have an obvious unfair advantage. But when they do agree, we're hitting it out of the park.
But what would be the most common reason you'd find they disagreed?
It really comes down to probably some really unusual ACD, but in most cases when they don't agree, it's an out-of-bounds calculation for the Hill.
Do you regularly repeat measurements with the same device and compare those calculations versus using multiple devices and multiple formulas?
I typically don't repeat them unless they don't meet validation criteria. But what I do, and this is extreme, but I get Pentacam, Cassini, IOL Master, Lens Star, Atlas, and eye trace on every patient.
Thank you very much.